All right, welcome back. Let's learn access permissions, how to set them, how to read them. There's a bunch of special permissions too we're going to go over. Let's go over that now. Yep, we're configuring. Yep, we're going to talk the standard, the special permissions, and what's called access control list. All right. We've talked about the principle of least privilege before. The principle of least privilege is fairly straightforward. Only give to your users what they need to do their job. So one extreme, the opposite extreme of least privilege, is if you made every single user in your system a root user. That means literally anybody in your system can destroy everything about your system. So the new employee who's only been working for a couple days, that's bad. That's why we do principle of least privilege. It's also good cybersecurity practice. The extreme of using least privilege is having someone who can't do anything, so making sure that nobody can do anything. Well, that's not practical because you're going to have people who need permission to do things, to do their job. We're working in this computer system. That's least privilege. Fairly straightforward. Access levels. In Linux, there are 3 basic access levels. I think we've seen them before, but you can read, you can write, and you can execute. And access levels depend on, they get tagged to the file, they get tagged to the directory. Take a text file, for example. Read permission means you can open it and read it. That makes sense. Write permission means you can open it, read it, and change it. Okay, that makes sense. And execute means you can actually run the file. Now, in the file sense, the only files you can execute are executable files. So programs, batch files, things you can actually execute, scripts. Now, directories are a little different. It's not like a one-to-one interpretation. Reading a directory means you can run the list command and see what's inside it. Writing a command or writing a directory means you can change the files inside it. And having execute permission on a directory means you can actually go into the folder. And this is kind of like, it's kind of interesting because you can have strange combinations of these permissions, but think of execute permission. Think of a directory as like a room. Execute permission is like having the key to go into the room. Write permission is having permission once you're in the room to actually like shuffle things around. And then read is kind of like having the ability to peek in through a window in the room, but you can't do anything inside of it. So it's a little funny. There's 3 different levels of access identities. Basically, permissions are broken out into 3 different groups, and you're going to see this. You have your basic user level. So user level permissions, you have your group level permissions, and then you have everybody else. And I'm going to show you what this means in a second whenever we review what it actually looks like. So permissions are, you can look at permissions for any file or folder. Let me show you. And it's going to look like this cryptic string of what the heck is going on. Hold on, there we go. So when I'm looking at this, when I run the list command, this string right here is telling me the access permissions for this. I think this is a folder. Yeah, that's a folder. So for the folder Sally, this string is telling me all the different access permissions for the folder Sally. And this is called a permission string. And we're going to walk through how it's broken down. So the first field in this string right here is going to tell you, is this a file or is this a folder? So when I run the list command, you can see here, it's got the D in front of it. That means it's a folder. But if I go ahead and if I just change into the user directory, whoops, all right. Now, if we look here, I know that file1 is a file, and you notice that the first character is a dash. That means it's a file. All right, so that first field in the permission string is file or folder. The next 3 characters in the permission string is the permission of the user that owns the file. And let me walk this back. Remember, when you create a file in Linux, it's going to tag whichever user you are, it's going to tag you as the owner of that file. And whichever group, whatever your primary group is, remember, you always have a primary group as a user, it's going to tag that group as the group owner of that file. And because Linux breaks permissions into user, group, and other, the first set of permissions that we're looking at here is actually the owner of the file. So the user that created the file, basically. So we have the user that created the file, and we've got this string, and it says rwx here, and it says r dash dash, and it says rw dash here. Now the rwx, we're going to learn, is the symbolic representation of the 3 levels of permission. And the 3 levels of permission are read, write, and executable, remember? And both a file and a folder has read, write, and executable permissions. And in this instance, I'm looking at this top line right here, and it says D, so it's a directory, rwx. Well, the rwx means that the owner of this directory has read, write, and executable permissions. So if you see the letter, that means they have the permission. If you don't see the letter, they don't have the permission. So if I go down to this bottom row here, I'm looking at a file, and it says rw dash. That means the owner of this file, student 5, has read and write permissions, but can't execute this file for whatever reason. So the first 3 characters of the permission string are the user permissions. Let's keep going. The next 3 characters are the group permissions. These are the permissions that the group has. So in this instance, it's the same logic. All right, we've got the symbolic representation of permissions, and it says r-x. So that means this is a directory. The second entry here, remember, it goes user group. The second entry in this line of the list command is the root group. So root owns this, and the group root owns this folder. And the group root has read and executable permissions, but doesn't have write permissions. Hopefully it's making sense. It'll start to make sense with more examples too. And again, the last 3 characters are everybody else. So when you set permissions for a file or a folder, the way that Linux looks at it, or the way that Linux checks your permissions, like let's say I want to make changes to one of these files. Well, the first thing it's going to ask is, are you the owner? Are you the owner of this file? Okay, and then it's going to check, okay, does the owner have permission to change this file? So is there a W in the first 3 characters? Okay, let's say you're not the owner. Okay, Well, are you a member of the group that owns this file? Okay, well, in this instance, root is the group that owns this file. So if I want to change this file, am I a member of the root group? And then, okay, going even further, does the group have write permissions? So this second set of characters, these RWX here, and there's a W there, so yes, you do. But let's say now you're in the scenario where you're not the owner and you're not the group that owns this file. So what are you going to do? Well, that's why you have the other field, or everybody else. And it says here on this second row, everybody else that's not the owner of the group, that's not the owner of the file, that's not a member of the group, everybody else can only R dash dash. So they can only read the file. Okay? Let's keep going. There's two ways that you can set the permissions, and we're going to be using the chmod command. But there's two notations or two representations of permissions. One, which I prefer because it's just easy to read, is the symbolic mode. And we're going to get into that. But this is the mode that has the actual characters W, R, X, which correspond to read, write, executable. And then it has the characters U, G, O, which correspond to user group owner, or user group other. Sorry. Let's talk about, there's also a number system. So if you want to change this permission, if you want to use the, and we're going to go into this command, but the chmod command, if you want to change read, write, and executable permissions with numbers, you can. 764 actually represents the permissions for the user, the group, and everybody else. And there's a warning here that you will have to be able to understand both modes. Let's talk about the absolute mode. Start from the beginning. Read, let's say read equals 4, write equals 2, and execute equals 1. I have a scenario where I want to give all of the permissions. The way I represent that is in one unique number, and it's the sum of all the permissions that I'm going to give them. So it's saying in this instance, we have 4 plus 2 plus 1. That's 4 plus 2 is 6. 6 plus 1 is 7, okay? So 7 represents all permissions available. So the absolute mode is a numeric representation of permissions where on one extreme you can say 0, which means no permissions. All right, I didn't give any permissions. And on the other extreme, I gave all of them, or 4 plus 2 plus 1, which is 7. Now, it gets a little tricky when you start mixing up different permissions. So in this instance, right, this is how you read this. I want to give a group read permissions and executable permissions, but not write permissions, so R-X. All right, so remember, read equals 4, executable equals 1, and the combination of these, 4 plus 0 plus 1, is equal to 5. So when I'm changing permissions with the numeric notation, or this